Assalamualaikum. We are from S3G2 Group 6. Today we are going to present about our database system project, which is the cinema booking system. As we all already know, entertainment has become part of our daily lives. As a matter of fact, it might also be part of the necessities and may be a short escape from the stress of our never-ending daily life problem. There are many types of entertainment to the point that it is actually uncountable. As for cinema, cinema is an establishment which is a theatre where films are shown for public entertainment in exchange for money. This system are not limited to only films, because nowadays there's even an option for us to choose our types of seat, food, how many seats that can be purchased, and also we can choose our movie experience by choosing a great cinema hall such as IMAX and 3D. Furthermore, the cinema booking system will be used where the cinema company display their offer to the user as they are the one who gaining the license for the movie. The cinema booking system is a ticket reservation system that allowing bookings in a few easy steps. Users can also process online payments, manage reservation, and customize events. This allows the user to purchase their desired movie ticket before the film was played for that week, anytime and anywhere. Okay, I think that's all from me. Thank you.
So now I will present a database system design for a cinema ticket booking system. The goal of this design is to ensure that movie schedule, user management, seat bookings, and payments are seamlessly integrated into a well-structured database. I will explain more details about each entities. For the first one, cinema entity, it's for represent individual cinema locations. The attributes for this entity is cinema ID, which is a primary key, name, the name of the cinema, locations, the address or area where the cinema is located, and lastly contact details, the information for contacting the cinema like a phone number or email. Next we have movie entity. The movie entity stores details about the movie being screened. The attributes for this entity is movie ID, which is primary key, title, the name of the movie, genre, the category of the movie such as action, comedy or drama, and lastly rating, the movie's rating. Next we got schedule entity. The schedule entities connects cinemas, movies, and showtimes. The attributes for this entity is cinema movie ID, which is primary key, cinema ID, foreign key, movie ID, foreign key, date, the date of the screening, time start and time end, the start and end times for the screening. Next, we have seat entity. The seat entity handles seating for specific schedule. The attributes for this entity is seat number, primary key, cinema movie ID, foreign key, and price. The next entity, which is user entity. The user entity stores information about system users. The attributes for this entity is user ID, which is primary key, name, the user's name's email, the user's unique email address for login purpose, password, the user's encrypted password, role, the user's role, either admin or customer. Next, we have booking entity. The booking entity manages reservation made by users. The attributes for this entity is booking ID, which is primary key, booking date, the date when the booking was made, total price, the total cost of the booking, payment status, track the status, user ID, foreign key, links the booking to user, payment ID, which is also foreign key, links the booking to a payment record. We also have payment entity. The payment entity stores details about payment made for bookings. The attributes for this entity is payment ID, which is primary key, payment date, the date the payment was made, amount, the total amount paid, payment method, which is the method that the user uses for payment. And lastly, for booking seat entity, which is the bridge, the booking seat entity links specific bookings to individual seats. The attributes for this entity is booking ID, which is primary key and foreign key, and seat number, which is also primary key and foreign key. The next, I will explain the business rules for this ERD. First one, we got cinema and schedule. Each cinema can have multiple schedules. The schedule also links a movie to its showtime at a particular cinema. Second, we got user and booking. Users can make bookings, and each booking is associated with a payment and specific seats. Third, we got seat and booking seat. A seat can only be booked once for a particular schedule, ensuring proper availability. Each cinema can host multiple movies at different schedules. User management. Users must register with a unique email. They can be either admins or customer. Booking and payment. Customer can book one or more seats for a schedule. Payments can be made via multiple methods, ensuring flexibility. Seat availability. Each seat is uniquely identified and linked to a specific movie schedule. A seat cannot be double booked.
Alright, this is our cinema booking system CBS table. First we have user table, which consists of attribute names, description, data type, size, format, range required, default value, unique, PKOFK, and FK refer table. Attribute names, we have user ID, name, email, password, and role. The description is for the attribute names. All of them have a description. The data type for the user ID is identity, and varchar for others. The size for user ID is 10, name is 255, email, password and role is 50. There is no format and range for these attribute names. The only attributes name that is required is user ID. It is auto requirement. The unique attribute names is user ID and email and role only. User ID is picky. Next we have cinema table. Attribute name, we have cinema ID, names, location, contact details. Description for the attribute names, data type, identity for cinema ID, and varchar for the rest of them. Size for cinema ID is 10, 100 for name, 250 for location, and 255 for contact details. There is no format and range for these attribute names. The cinema ID, name, and location is required, but contact details is no. The only unique attribute names is cinema ID and name, and cinema ID is the picky. Third, we have movie table attribute. Names is movie ID, title, genre, and rating. For the description, same as earlier. Data type, int for movie ID, for title and genre, and integer for rating. The size is 10 for movie ID, 200 for title, and 100 for genre. Format, there is no format. Range, only for rating, 0 to 10. Is this required? Yes, for movie ID, title, and rating. There is no default value. The only unit is movie ID and it is named as PK. Next is booking table. Attribute name is booking ID, user ID, movie ID, cinema ID, booking date, seat number, and payment status. Data type is int for booking ID, user ID, movie ID, and cinema ID. Decimal for booking date and FARCA for seat number and payment status. Size is 10 for booking ID, user ID, movie ID, and cinema ID, and seat number, but 50 for payment status. Range, there is format for booking date in day, month, and years. Range, there is only payment status, which is paid or pending. The unit ID is only booking ID, and it is as a PK and FK for user ID, movie ID, and cinema. FK refer table, we can refer user ID in user table, movie ID in movie table, and cinema ID in cinema table. Table number 5 is payment table. We have payment ID, booking ID, payment date, amount, and payment method. We have data type. Size is 10 for both payment ID and booking ID. Format only for payment date, month, and year. Range is only for payment method. Is this required? Yes, all of them. There is no default value. The only unit is payment ID and act as a PK, and booking ID is a FK, which can refer in the booking ID table. Next, we have claim table. Claim ID, booking ID, claim reason, claim status, and resolution. Data type, we have data type, we have size 10 for claim ID and booking ID, but 50 for claim status, and range, which is pending or resolved. The only unit ID here is claim ID, act as a PK, and booking ID is FK, which is we can refer in booking ID table. The seventh table is report table. Attribute name is report ID, report type, generated date. We have description, the data type is int for report ID, size is 10, for report ID and 100 for report type. The format is only for generated date, month, and years. There is no range required or default value for these attributes. The only unique attribute here is report ID, which is PK. The last table is cinema movie table. Attribute name is cinema movie ID, cinema ID, and schedule. We have description for all of these. The data type is int for 3 of them and date time for schedule. The size is 10 for 3 of them, but there is no size for schedule. The only format is for schedule, which is day, month, and year. The only required here is cinema movie ID, and it is unique and act as a PK.
As for the DML insert statement, the first query is insert a new row into the user table for all column. This is the SQL statement. And the result will be something like this, as in the table. For the DML update statement, the query is change the email of Muhammad Afif to afnafazadi@yahoo.com. And this is the SQL statement that will update the DDL statement above. And this is the DML delete statement, query delete all staff role in this table user. And this is the SQL statement, delete from user where the role equal to staff. And this is the DML select binary operation. And the query is to retrieve the role manager. And this is the relational algebra, sigma role equal to manager in the user table. And this is the SQL statement, select all from user where role equal to manager, which will result in something like this. And then the DML select aggregation and grouping operation. The query is to retrieve the location of the cinema and their phone number in Kuala Lumpur, and this is the relational algebra to find the location, contact details in Kuala Lumpur from the table of cinema. And this is the SQL statement, select location and contact details from cinema where location is Kuala Lumpur, and it will be grouped by location and contact details, which will result in two location, which is Surya LCC Kuala Lumpur and Mid Valley Mega Mall Kuala Lumpur. And this is DML select inner and outer join operation. For the query is the list the movie names, genre, rating, cinema name, location of the cinema, and cinema contact details. And this is relational algebra, pi title, genre, rating, cinema name, location, contact details from movie, inner join cinema movie, inner join cinema. And this is the the SQL statement, select title, genre, rating, name, and rename them as cinema name, location, and contact details from movie, from the table movie, and join with cinema movie and cinema, which will result in this. And then we have DML select next to end sub query operation. Query is display the movie count in the cinema. Select statement is this is the SQL statement, and this is the relational algebra, which then will result in three final result to the uh, to the nested subquery.